Hello students and welcome to our today's class. Today we are going to talk about a shape that is known as a cone. A cone is a figure that has got a shape that resembles the following. It has a circular base and then it has a common vertex like that. And all this side is actually enclosed like that. So we have got a circular base. We have got a circular base, and this is normally known as the slant height. And from the center of the base to the vertex there, we normally have the perpendicular height. We have the perpendicular height. And then from the center to the circumference like this, we are going to have the radius. So a shape that is going to behave or to have this kind of scenario is what we normally refer as a cone. As far as a cone is concerned, we are going to be interested in two things: how we calculate the surface area and how we calculate the volume of a cone. Today's class, we are going to focus on the surface area of a cone. Whenever you have been given a cone and then you are told you compute the surface area, then you should be able to understand that the surface area of a cone is normally given by the area of the base. Remember the base, we said it is circular, so it is pi r squared plus the area of the curved surface, which is normally given by the formula pi r l. So this is how we normally get the surface area of a cone. Like for example, you can be told that a cone has a base whose radius is 10 centimeter and perpendicular height is 8 centimeter. Now you are told you calculate the surface area. So first of all, I need to explain that the R that we have here, pi RL, this R is actually the slant height. The R here is the slant height. This height from the top here to the actually the circumference of the circle at the base, this particular length is normally called the slant height, and it is normally represented by L, as I said here. So if you are given information like this, you are told that the base radius, that is from the center to the circumference of the circular base, from the center here to here, you have been told that this distance is actually R is 10, and you have been given the perpendicular height. The perpendicular height, you have been told that this height here from the center of the base to the center of the top is what we call the perpendicular height. So you need to differentiate the two. You need to know the perpendicular and the slant height. The slant height is from the top to the circumference of the circle here. So it's going actually to be slanting. Whereas from the top, from the center of the vertex to the center of the base, this one is known as the perpendicular because it's going to make an angle of 90 degrees with the base. So this one, you have been told in this question, it is 8. And therefore, we are lacking, or we don't have the slant height. We don't have the slant height, but you can be able to note we have got something like a right angled triangle where here we have it is 10 centimeter and here it is 8. And having discussed about the Pythagoras theorem, we can be able to get this particular slant height, and which is actually going to be like our hypotenuse, which is the same as R in this particular case. And how do we get the hypotenuse? Hypotenuse is normally given by the square root of the base squared, which is 10 squared, plus the height squared, which is the 8 squared. So it's going to be 100 plus 64. We take the square root, and we are going to find it to be what? To be the square root of 164. It's going to be the same as the square root of 164. So we need to come here and get our calculator. We get our calculator here, and we do the computation. And the computation that we are going to do here, it is the square root of 164 the square root of 164 just a minute. And that will be your strand height. Your strand height, so is going to be a figure that you can be able to get. And once you get that figure, you just get it as your L, and then you move ahead now to get the surface area. In this case, we can say it is 22/7 times the radius, which is 10 squared, plus 22/7 times the radius, which is 10, times the strand height, which is actually the root of 164, and then you can be able to calculate it like that. I am not able to share my screen of the calculator because actually I'm sharing the screen of this particular video. So you can be able to determine it like that. So having obtained that, you can be able also to solve as many questions as possible as far as the cone is concerned. As far as the cone is concerned, you can be able to solve as many questions as possible. So in that particular case, I want us to have another discussion. This one is giving me an answer of 164 is actually 12.8. That is actually the square root of 164. So you can simply come here and compute this. You can compute this and be able to get the final answer. So let us see how our answer is going to be. So it's going to be 22/7 times 10 squared by r squared plus 22/7 times 10 times 12.8. So in this part is going to be 22 times 100. You find that is going to be 314.28 plus 22 times 10 times 12.8 is equal to that, divided by 7. You get is going to be 402.29. So you get it, you add to 314.28. You find is the total surface area will be 716.56 centimeters squared. That is the surface area for that particular figure. You can also be given a scenario like this. You are told that the surface area of a cone is 549 centimeters squared. Find the radius of the cone if the slant height is 13 centimeter, like that. You have been given the surface area. You have been told it is 549, and you have been given the slant height, which is R. You have been told is 13 centimeter. Now you are supposed to calculate the the radius of that particular cone. So one thing you need to understand is that the surface area is given by pi r squared plus pi rl. In this case, we are told that the surface area is 549 should be equal to 22 over 7 times the radius, which we don't know, squared, plus 22 over 7 times the radius, which we don't know, times 13. Then you'll be able to realize that 549 should be equal to 22 over 7 r squared plus 22 times 13, 286 over 7r. So if we can divide this, 22 over 7, we are going to have that 549 is equals to 3.142 r squared plus 286 divided by 7, which gives us 40.86 r. Then from there now, you can rearrange this one to be a quadratic equation and say 3.142 r squared plus 40.86 r minus 549 should be equal to 0. And this one now can be solved quadratically for us to be able to get the value of r, which is actually the radius. So it is not a must that you always will be told to calculate the surface area. But the good thing that you need to understand is that you can be given anything and you can be asked anything. So the last kind of a scenario maybe I can be able to illustrate here, it is when you have been given a cone like this. You can be told that this one is maybe 14 centimeter and this one is maybe 6 centimeter, and now you have been asked to calculate the surface area of this. Remember, you have not been given the radius. The radius here is actually missing. So what you need to do, you apply the Pythagoras theorem in this case. Here you have been given the slant height, which is the same as the hypotenuse, and you have been given the height, which is 6, you can be able to get actually the base, which is actually the same as the radius to this particular cone from the here to here, this distance here. So you can come here and say radius squared is the same as the square root of 14 squared minus 6 squared. So what are we going to get? 14 squared gives us 196. 196 minus 36. You get actually r is equal to the square root of 160. So what is the square root of 160? It is 12.65. So r will be equal to 12.65 centimeter. Now you can come here and actually calculate the surface area, and you say the surface area will be given by pi r squared, which is 22 over 7 times 12.65 squared plus pi rl, which is going to be 22 over 7 times 12.65 times r, which is 14, the slant height. And then you can be able to get the area of the base first, and then you add to the area of the curved surface, so that you can add them so that you get the surface area of that cone. So that is how you are supposed to maneuver whenever you are given such kind of questions. Thank you very much.